In this video, I'll focus on some challenging mathematical problems regarding the concept of ratio that you might encounter. So let's jump straight into the video. We'll focus on the mathematical concept of ratio. So if I go through a brief overview before going into the problems, and if I go to open a new tab and search ratio mathematics, something along the lines of this. So it shows the definition of ratio in mathematics. So in mathematics, a ratio shows how many times one number contains another. For example, if there are 8 oranges and 6 lemons in a bowl of fruit, then the ratio of oranges to lemons is 8 to 6, which is equivalent to the ratio 4:3. So the ratio of oranges to lemons here in this bowl of fruit is 8:6. So for every 6 lemons, there are 8 oranges. So I hope you get a brief idea of what a ratio is. So now we'll go to problem solving. There are 3 categories here: medium, hard, and very hard, and I will focus on the hard part. So let's focus on the first problem and read the problem. So what does it say? Person Suha has a full 600 milliliter bottle of wallpaper remover. So she is going to mix some of the wallpaper remover with water. So here is the information on the label of the bottle. So the label says the wallpaper remover has on the label of the bottle, it has 600 milliliter of wallpaper remover, and you have to mix 1/4 of it, or 1/4 of 600, or 150 milliliter of the wallpaper remover with 4,500 milliliter of water. So Suha is going to use 750 milliliter of water. So how many milliliters of wallpaper remover should Suha use? You must show your work. So if I use my pen tool, so it says on the bottle, it says what? It says 600 milliliter so 600 milliliter of wallpaper remover is available in total. This is the amount of wallpaper remover. So 1/4 of it is used. 1/4 of it is used. So which is what? 1/4 of 600, right? So this is 150, or 150 milliliter of wallpaper remover is going to be used by Suha. So now 150 milliliter of wallpaper remover is mixed with 4,000 milliliters of water. So this 150 milliliter is used with what? 4,500 milliliter of water. So what is the ratio of wallpaper remover, let's say WR, is to, or ratio to water, let's say WA. So the ratio of wallpaper remover is to water is what? We can also write this as WR divided by WA, or wallpaper remover divided by water. So this is what? What is the ratio? So the ratio is, for every 150 milliliter of wallpaper remover, I'm using 4,500 milliliter. So this is for every 150 milliliter, 4,500 liters of water is used for every 150 milliliter. So what is the ratio? So if I cut this, I get what? 15 divided by 450, or it's something along the lines of 1/30. So for every 1 milliliter of wallpaper remover, 30 milliliters of water is used. Okay, so what is required in the question, in the problem? So how many milliliters of wallpaper remover should Suha use for 750 milliliter? So for 30 milliliter of water, 1 milliliter of wallpaper remover is used. So what should be used for 750 milliliters of what? How much wallpaper remover should be used for 150 milliliters of water. So I can give an equation here. I can give an equation. X for 1 milliliter of wallpaper remover, I use 30 milliliter of water. So what is the value of X? The value of X is what? If I take it here, so X would be 750 by 30 or 75 by 3. So if I divide 75 by 3, I get what? I get 3 2s are 6 and 1 5 3 5s are 15. So X is, the value of X is 25. So for every 25, so for 750 milliliters of water, Suha is going to use 25 milliliter of wallpaper remover. So how many milliliters of wallpaper remover should Suha use? She should use 25 milliliter of wallpaper remover for 750 milliliters of water. I'll now focus on problem number 2, which says in a company the ratio of the number of men to the number of women is 3 to 2 or 3:2. So the 40% of the men are under the age of 25. 10% of the women are under the age of 25. So what percentage of all the people in the company are under the age of 25? So if I use my pen tool, the question says that the number of men to women is 3 to 2. So the ratio of men to women is 3:2. So we can also write this in this way. Let's say the number of men is what? Thrice x. So the number of women is twice x. X is an integer number. Okay, x is a number. So the number of men to the number of women, the number of men to number of women is thrice x is 2 or 2 twice x. So what is the total number of population? The total population is what? Thrice x plus twice x, which is 5x, right? So this is the total population. Just keep that in mind. Okay. So 40% of the men are under the age of 25. So 40% of the men. So what is 40%? 40% is 40 by 100, or I can also write 4 by 10 or 2 by 5, right? So 2/5 or 2 by 5, 40% of the men. What is the total number of men? We assumed thrice x, right? So 2/5 of thrice x is what? The total or the population of men who are under the age of 25 or 25 minus. Okay. So 2 thrice x is what? 6x by 5. So this population is under 25 of men. This is the number of men. This is the number of men who are under 25. So what is the number of women who are under 25? 10% of the women are under the age of 25. So 10% means 10 by 100 or 1/10. So this is what? 1/10. Okay. So 1/10 of the women. What is the women that we assumed? Twice x, right? This is the number of women. So 1/10 of twice x. This amount of women are under the age of 25, right? 25 minus or under the age of 25. So this is what? Twice x by 10 or x by 5. So x by 5 this is the number of women who are under the age of 25. Okay, so this is the number of men who are under 25, and this is the number of women who are under 25. So what percentage of all the people in the company are under the age of 25? So what is the percentage of all the people? So for all the people, we know that the total number of people is what? 5x, right? So the total number of people is 5x. The number of men under 25 is 6x by 5. 6x by 5. The number of women under 25 is x by 5. X by 5. So if I add this, so this is the ratio of the number of people who are under 25 to all the people. This is the total number of people. So what is the ratio? If I simplify this, so this is 5, and this is in the denominator is there is 5x. So here is 6x plus x, which is 7x by 5. So we can also write this as well. If I take the 5 down here, so 5 multiplied by 5 is 25. 25x, and this is 7x. So if we cut the x part, so we get what? 7 by 25. So the ratio is what? We can also write this ratio as 7:25. So this is the ratio of the number of people who are under 25 by the number of people, the total number of people. So this is the ratio, 7:25. So this is the or it requires the percentage. So if you want to figure out the percentage, what you can do here is you can multiply this ratio by 100. So what do we get the ratio? 4. So we get what? 28%. 7 multiplied by 4 is 28. So 28% of all the people are under 25. Now let's focus on problem number 4. So let's read the problem. So it says there are only blue pens, green pens and red pens in a box. So the ratio of number of blue pens to the number of green pens is 2:5. The ratio of number of green pens to the number of red pens is 4:1. So there are less than 100 pens in the box. So what is the greatest possible number of red pens in a box? So let's attempt this question. So as you can see, there are only blue pens, green pens and red pens in a box. Keep that in mind. Okay, so the number of blue pens to the number of green pens is 2:5. So the number of, if I use my pen tool, the number of blue pens, let's say B, to the number of green pens is 2:5. Okay, and the number of green pens to the number of red pens is 4:1. So the number of green pens is to the number of red pens is what? 4:1. Okay, so if I want to make or to figure out the number of the ratio of blue pens to green pens to red pens, so the number of blue pens is to the number of green pens is to the number of red pens. So how do we do that? As you can see, green pens is common in both of the ratios. So if I want to merge these two ratios into a three colored ratio, blue, green, red, as you can see, green is the common one, but you can see that the number here is the ratio numbers are here differently. So in this case, the first case the ratio is 2:5. In the second case the ratio is 4:1. So the green here is 5, the green here is 4. So what I can do is, how can I make both of these common? So in order to make both common, we can do an LCM or lowest common multiple of 5 and 4. So what do we get when you do 5 and 4? We can just simply multiply 5 with 4 and we get 20. So this is the common value. So in order to make 20, what do we need to do here? We have to multiply both of them by 4, because 5 multiplied by 4 is 20. So you have to multiply 2 with 4 as well. So what do we get here? So if we multiply 2 with 4, we get 8 is 2. If we multiply 5 with 4, we get 20. Okay, so we'll do the same here as well. So in order to make this 420, we have to multiply both of them with 5. So we have to multiply 4 with 5 and we have to multiply 1 with 5 as well. So what do we get? 4 multiplied by 5 is 20 is 2. 1 multiplied by 5 is 5. So the ratio of blue to green is 8 is to 20. The ratio of green to red is 20 is to 5. Now we can merge these two together. So what is the ratio of blue to green to red? The ratio of blue is 8, as you can see here, 8. The ratio of green is what we made common, which is 20, and the ratio of red is 5. So this is the merged ratio of the three colors, blue, green and red. So as you can see here, there are only blue pens, green pens and red pens. So the total number of pens consists of only these three colors, blue, red, green and red. So there are less than 100 pens in the box. So the total number of pens, let's say total T, is less than 100, the total number of pens. Okay, so as you can see, the ratios are given and the total number is less than 100. So what is the greatest possible number of red pens in the box? So what was the ratio of red pens? 5. So what is the ratio of red pens to the total number of pens? The total number of pens is what? 8. In this ratio, we have what? 8 plus 20 plus 5. So we have what? 5 by 33. So this is the ratio of red pens to the total number of pens. So this is the ratio. So let's say this is Tn. So the total number of pens. So the ratio of red pens to the total number of pens. This ratio is what? 5 is to 33. This can also be written as 5 is to 33. Okay. So if the ratio is given as 5 is to 33, so what is the total number for each? We can also write from here is for each 33 pens, for each 33 pens, the number of red pens is 5. So for each 100 pens, we get what? 5 divided by 33 multiplied by 100. So we get what? 500 divided by 33. So if we just simply use the calculator and just do a brief calculation, 500 divided by 33, we get what? 15.1515, etc. So this is somewhat, let's say approximately 15.15 will omit the fraction because we need whole number. So this is the maximum possible number of pens. This is the maximum greatest possible number of red pens, because there is no fractional pen, there is only one pen or a like whole number pen. So the number of red pens can be what? This is the number of pens and this was the ratio. So the greatest possible number of red pens is 15. I'll focus on problem number 6 of the hard category now. So we have been following the hard category from the beginning. So in the problem number 6, let's read the problem. It says 360 pound is shared between Abby, Ben, Chloe and Dinesh. So there are 4 persons here and 360 pound is shared between these 4 persons or among these 4 persons. So the first information given here is the ratio of the amount of Abby gets to the amount of Ben gets is 2:7, and the second information here is the Chloe and Dinesh each get 1.5 times the amount Abby gets. Okay, so if I use my pen tool, you'll use the first information first. So this is the ratio of the amount Abby gets to the amount of Ben gets is 2:7. So the ratio of what Abby gets, the ratio of the amount of Abby to Ben is 2:7. Okay, and the second information here is Chloe and Dinesh each get 1.5 times the amount Abby gets. So the ratio of Chloe and Dinesh is basically what? This is 1.5 times the amount Abby gets. So Abby gets in the ratio Abby gets 2. So Chloe would be what? 1.5 times the amount Abby gets in ratio, and Dinesh will also get 1.5 times the amount Abby gets. So if I multiply the ratio, we get what? 3:3 for Chloe and Dinesh. Both of them get 1.5 times the amount Abby gets. So in terms of ratio, we can write Chloe is to Dinesh is 3:3. Okay, so work out the amount of money that Ben gets. So what, these are the 4 persons for whom 360 pounds is divided, right? This is the total number of money, total amount of money, 360 pounds. So, and 4 persons share this amount of money. So this amount of money is shared between these 4 persons, only these 4 persons. So if I add all the ratio, we get the total number in terms of ratio. So 2 plus 7 plus 3 plus 3. So this is what? This is 9 and 6. This is 15, right? So let me just use the pen tool. So this is 15 is the total number of money in terms of ratio. So what does Ben get from this? Ben is what? This 7, right? So amount Ben gets is 7 in terms of ratio is 7 by 15 or 7 is to 15 or 7 is to 15. Okay, so this is the ratio that Ben gets. So this is what Ben gets, and this is the total in terms of ratio. Okay, so 360 pound is divided. So for each 15 pounds, Ben gets 7 pounds. So for each 360 pounds, Ben gets what? 7 by 15 multiplied by 360. Okay, so 15 and 360 can be divided by 15. So we get what? 360 divided by 15 is 2 and 64. Okay, so 24 multiplied by 7 is what? 20 multiplied by 7 is 140, and 4 multiplied by 7 is 68. So 168 pounds is the amount that Ben gets. This is what was required in the question. I hope you get an idea of how you can solve these type of challenging ratio problems. So in the next video, I'll focus on some more problems regarding this topic. So stay tuned for that.